Okay, class, welcome back. Today is lecture 10. Today we're going to talk about factoring. So it's very much related to what we did last time. So let me remind you of that. Last time we learned how to multiply and divide polynomials. So something like this we could multiply out, and things like this are the most common types you'll ever have to deal with. So we can multiply this out, and I'll let you do it on your own, but if you do it and then you simplify, you'll end up with something like this. So we learned how to do that. But then what we want to do now is think about something called factoring, which is a little bit more interesting. And we're also going to compare it to how it works with numbers. Okay, so just like with numbers, we can instead start with something already multiplied out and attempt to factor it. So, for example, something like this, you can just start with 64. And so the idea is, instead of starting with two things to multiply together, you just start with the final product. So we're just starting with 64. And then how do you factor 64? Well, you divide things out. So if I divide by 4, for example, if I do this little long division technique, so let me do it real quick, then I'll get 16 and I'll get a 0 as a remainder, which tells me that 4 is in fact a factor. And what it means is that not only is 4 a factor, but it goes into 64 16 times because I got 16 up there. And so dividing helps us factor. So I could do the same thing with polynomials. That's the nice part. So for example, I could start with this polynomial, which is the same as the polynomial I have at the start. I wrote down earlier, and I could try to factor it by dividing by x minus 4. And we already learned how to do this, so I don't really want to go through the whole process again. I mostly just want you to compare. If you do that whole process, you will end up with 2x minus 3. So I'll leave it to you if you want to practice in that process again. But what does this really mean? Well, you'll get a remainder of 0 once you finish again. And so just like with numbers, the remainder of 0 tells you that 16 is how many times 4 goes into 64. Well, remainder of 0 here tells you that if I multiply x minus 4, it'll go into 2x squared minus 11x plus 12. It'll go into it this many times, meaning I multiply by that, and I will get 2x squared minus 11x plus 12. And in fact, that's what we said at the very beginning. What happened if I do multiply these out? I will get that. So multiplication and division are opposites of each other, but multiplying things out and factoring them are also opposites of each other. So multiplying these two out is the opposite of starting with this thing and factoring out an x minus 4 by dividing it out, and then the leftover will be 2x minus 3 when you do the long division. But what is the problem with this? This is actually not exactly what we're going to do today because of some issue. This is only useful, or this only works if you already have something to divide out. If you know what to divide by. So when I started with 64, I knew to divide by 4 and that would help me factor it, factor 4 out. to get me 16. But if I say like, okay, here's a big number, factor this number, 792,397, and I don't give you something to divide by, it's incredibly hard. You can't just do it. So factoring is actually very, very hard to do. You need to know what to divide by first. If you want to do it that way. And the same thing happens with polynomials. I need to know what to divide by. So if I just gave you this thing, and I didn't tell you to divide by x minus 4, then you wouldn't know any of that. And so where would you go? You would just be stuck. How would you factor that? How would you factor something out if you don't know what factors out? And so that's what we're going to learn today, is to do things like that. Okay. So what we're going to do is learn some techniques to help us with this situation. So we use some techniques to help us. So we're going to go from like sort of easy to hard. So the first kind of polynomial that will factor are things like this, 2x plus 16. So to factor something like this, factoring, remember, means that it should equal something times something else. That's what we're trying to do. Figure out what it is. What are these things that what are we taking out, and then what's left, such that when we multiply it back together, we'll get 2x plus 16. Well, when you just have two terms like this, all we're looking for is what goes into this and what also goes into this. So what goes into both of these? What divides into them? Well, a 2. A 2x goes into 2, or sorry, 2 goes into 2x. How many times? X times. Just means that 2 times x is 2x. And 2 also goes into 16. 8 times. So the idea is that I'm factoring by dividing out this 2 that goes into both things. So the idea is you take out the 2, you're undoing the distributive property. So a 2 times x should get me back to this 2x. And it does, right? 2 times x is 2x. And a 2 times 8 should get me back to that 16. And it does. So this is the factorization. Of course, you don't draw those arrows because you don't want to go back. You just undid the multiplication. So you would just write something like this. 2x plus 16 equals 2, because 2 goes into both of the terms. It equals 2 times x plus 8, because 2 goes into 2x twice, or x times, and then 2 goes into 16 8 times. So you're just dividing out the 2 to both terms. And you could do it a few more terms if you want. So like 3x squared minus 9x plus 27. Generally, we don't want to factor just by taking a number out. This is not going to be the end of the factoring, but a 3 goes into all of these terms, so I can take out a 3. So 3 goes into x squared. Sorry, 3 goes into 3x squared 3 times. 3 goes into 9x, negative 9x, negative 3 times, and 27 9 times. So that's how we could factor that. So the first kind is just taking out a common divisor from each term. That's all we're doing. 3 goes into all the terms, so we can take it out. We can also take x's out if there's enough x's in every term. So something like this, I could also do something very similar. So a 5 goes into both of these terms. So I could take out a 5, but an x squared also goes into both of these terms. An x squared goes into x cubed how many times? Just one more x is all you need. So when I take out an x squared, there will still be one of the x's left. And I took out the 5, so there won't be any more numbers there. And then here, if I take out x squared, well, I've taken out all the x squareds, all the x's. So what's left is just a 1. I factored out everything, and so there's just a 1 left. But out of the 20, I factored out a 5, so there's a 4 left there. And so you could write 4 times 1 if you want, but nobody does that. You would just write it as 4. So it's really just 5x squared times x plus 4, because I've taken out 5x squared from both terms. You can also, let's do one more. Let's do something like that. So here, people generally like to have the biggest power of x not have a negative on it. So what they would want to do is take out a -3 from both of these, because 3 divides into 21. And for x's, well, this one only has 4 powers of x. So at the most, I could take out 4 powers of x. I can't take out more because there's not enough. So I'm just taking out -3 x to the 4th. And what's left here? Well, there's still x to the 6th left, but I've taken out the number and the negative. So it's just x to the 6th. Over here, because I've taken out a -3, there's now a -7 left, and I took out all the powers of x, so there's none left there. And that's it. So let me write it less colorful, just like this. Okay, so that's the first type of factoring, is just taking one thing out of every term. And so this is just always the opposite of a very basic distributive property. This is the opposite of doing one thing times a bunch of stuff. So for example, x squared times 2x plus 10 minus x squared. If I multiply this out, I'll get something else. And what I'm doing is just the opposite of multiplying out something like this. I'm just doing it in reverse. I'm taking out the same thing from each term. So you should think about it as the opposite of situations like this, or like 5x times 6x squared minus 2x plus 10. This comes from taking out a 5x from each term, which is the opposite of putting it in. Okay, but so that's the first type of factoring. But next, how about things like in the very first example I wrote today, where you have, what was it, 2x squared minus 11x plus 12, where, so here I'm not taking a number out from each term or an x out from each term, because this one doesn't have any x's and they have no number factor in common. 2 does not go into 11. So I'm not doing that kind of factoring. Instead, I ended up with x minus 3, I think it was, and like 2x, or sorry, it's x minus 4 and 2x minus 3. So how do we go from there to there? That's the next question. So we're not just taking one thing out of every term, we're factoring it a bit differently. Okay, so there's a couple ways to do something like this. The first is grouping. So it's called factoring by grouping. And it's best just to see an example, though we're not going to do this one very much. It doesn't come up so often. So we're just going to do one example. It's very situational where it works. So what we do is we do what we just learned in 2 parts. So we group, hence the name, group 2 terms at a time. So what we're going to do is we're going to think of these 2 just being together and these 2 being together and factoring them like how we just learned. So for example, what goes into both x cubed and negative 3x squared, and x squared goes into both. So from the first two terms, we'll take out an x squared, and what's left? Well, I only have one power of x left there, and I have no powers of x, but I still have my negative 3. Didn't take out a negative 3 or anything, so that's there. And then from the 4x minus 12, I can take out a 4 because 4 goes into both of these. My pen. Sorry, I have to pause while I fix my pen. No, what happened? Okay, I fixed it. So as I was saying, a 4 goes into both 4x and negative 12. So I'm going to take out a 4. And what's left? Well, if I take a 4 out of 4x, there's just an x left. If I take a 4 out of 12, I get a 3 left. And I didn't take out the negative, so it's still negative 3. And then we have a sort of very weird looking thing where now we think of it as, again, now there's just two terms, and we think of them as these two sort of strange looking terms. And what do they have in common? They have an x minus 3 in common. So actually I can factor out an x minus 3 from both of these terms. And if I take out an x minus 3, what's left from here? Well, just an x squared, because I divided out the x minus 3, so just the x squared is left. And what's left from here? Well, I divided out the x minus 3, so all that's left is that 4. And so now we've factored this. We factored out x minus 3. And what was left was x squared plus 4. So if you did long division, like we learned, if you started with this guy and you did long division and you divided out x minus 3, you would end up with x squared plus 4 on the top. Vice versa, if you would divided out x squared plus 4, you would end up with x minus 3 on top. So we did this without already knowing what would factor out. And then you can't factor any further. You might think you could factor this, but this actually does not factor any further. So done. So typically you want to factor as much as possible, but this doesn't factor. And so we're done here. We factored out as much as possible, and this is it. So why is this very situational? Let's see that. Well, if I just like do some random, I don't know. Let's see why it works up there, but not always. So the idea was that I took out x squared from both of these, and then what's left is x minus 2. And then I took out a number to factor this, but here, this one, there's no number that goes into 4 and 5, so then I'm stuck. And then I can't do that next step, because in that next step, the reason it worked was because x minus 3 was in both of these. So I would need this x minus 2 to be also over here. So because there's not an x minus 2 there, I can't really continue. So it's very situational. And so we're sort of not going to deal with it too much. Instead, we're going to practice factoring the most commonly necessary to factor things. And that is by using the box method. So in my experience, when you get really used to factoring, you don't actually need any methods anymore. You can sort of just see it. And that's the level of skill you should hope to attain, I think. But I will show you this anyway. And then when you're ready, you can stop using the box method. So the box method is for things like this. It's only for degree 2 polynomials, meaning nothing higher than a power of 2. That's the highest power you see, x squared. And here's how it works. it works by, we take advantage of one thing. Take advantage of knowing that if it factors, it doesn't have to factor out actually, but if it does, then it will look like, it'll always look like x minus a number times x minus another number. And I guess I'll just call them a and b. So these a and b are just two numbers. So we can just preemptively know, what happened to my pen again? 1 second. Okay, as I was saying, let's see. So we're taking advantage of the fact that if I can factor it, it's going to look like x minus a number times x minus another number. And so all we got to do is figure these two numbers out. And how do we figure them out? Well, we have to think about what would happen if I multiply this together. If I multiply this together, I'm going to get up x squared, x times x is x squared. And then I'm going to get x times negative b is negative bx. And then I'm going to get negative ax when I multiply these together. And then I'm going to get positive a times b. So the idea is that a and b will multiply together to be the number at the end, which would be negative 3 in this case. So a times b will have to be negative 3 because that's the only number. And this 2x will need to be the result of putting negative bx and negative ax together. So that will have to be 2x. So in other words, negative b minus a will have to be 2. So that is going to help us figure out a and b. Okay, but it seems a bit complicated when we write it out like this, but we can make it a little bit easier. The easiest way to think about it is first think about negative 3. So start with negative 3 and figure out what multiplies to be negative 3. So what multiplies to be it? Well, how do I get negative 3? I could do 1 times negative 3, or I could do negative 3 times 1. And that's it, right? Or sorry, that's the same thing. That's not what I meant. The second one should be, I could be negative 1 times 3. So I have to think about that. And then I'm going to think about which one of these two adds up to 2 if I add the two numbers. So then see what negative 3 plus, or let me put them in the same order. So then I'm looking at these two numbers and I'm adding them. So what's 1 plus negative 3 versus what's negative 1 plus 3? So the first one gets me negative 2. The second one gets me 2. So which one do I want? Well, I want the one that adds up to 2. So that's the idea. I have to think about what numbers multiply to be negative 3, but also add up to 2 at the same time. That's the idea. That's what we're asking about. So what numbers multiply to negative 3 and add to 2? And the answer is 1 and negative 3 do this. So this tells me how to factor. X squared plus 2x minus 3 is going to be x minus the first one times x minus the second one. So x minus 1 you would just write as x minus 1, and x minus negative 3 you would then write as x plus 3. And how could we check that we actually factored it right? Well, we could just re-multiply it out. So if I multiply it out, I should get back what I started with. So if I multiply it out, I'll get x squared minus x plus 3x minus 3, which is x squared plus 2x minus 3, which is the same as what I started with. So yes, this is the correct factorization. And now the box method is just doing this in a very sort of organized way where you draw, I don't know why it's called the box method, but you draw a diamond and you stick the two numbers that you're trying to add and multiply to on the top and the bottom. So on the top goes the 2, and on the bottom goes the -3, coming from this 2 and -3 here. And then on the left is A and on the right is B. And so you're just organizing this differently. So you're saying -3 needs to be A times B. And so that means -3 can be either 1 times -3 or 3 times -1. And then you're still doing the same thing, as though then you're checking if they add up to 2. So then A plus B here would be 1 plus -3 is 2, which is what we wanted. But A plus B here would be 3 plus -1, or sorry, the first one would be -2. Oops. The second one would be +2, which is what we wanted. So this is our A and B, 3 and -1. It doesn't actually matter which one you call A or which one you call B. You could switch them like I did here. So then this would tell you x minus 3, sorry, x. So wait, hold on, sorry, now I confused myself. Oh yeah, so this technique is, oh yeah, okay. Yeah, so this technique is not doing x minus a, x minus b. So then this one is doing instead x plus a, x plus b. So it's the opposite. So a is 3 and b is -1 here. Sorry, so now it's going to be a bit confusing but it's the same answer, 2 different ways. So in the first way, we're thinking about it using negatives, and in this box method, we're using positive a and b, but it amounts to doing the same thing. Okay, so this just takes lots of practice, so we're just going to practice more. It gets easier with practice, so let's do that. Factor x squared minus 11x plus 28. So first, we're going to think about 28. So what multiplies to 28? Well, there's a couple options this time. So I could do 28 times 1, 1 times 28, but I could also do 14 times 1, or sorry, times 2, 2 times 14. So there's quite a lot of options. 7 times 4. Sorry, I don't know why I'm switching orders. You only need 1 of each. That's unnecessary. Let's do that again. 28 times 1, 14 times 2, 7 times 4, and that's it. But since negative times negative is positive, there's actually 3 more, which is -28 times -1, -14 times -2, and -7 times -4. So there's actually 6 things that can multiply to be 28. So then which add up to 11? Which add to -11, if any? Well, because I got to add up to -11, these are all positives. When I add them, that's definitely not going to give me a negative. So it's got to be one of these underneath. So let's see, -28 plus -1, that's going to be -29. That's no good. -14 plus -2 equals -16, no good. Aha, -7 plus -4 does equal -11. So that's the one that we want. So how does this factor? Once you have our two numbers, how do we actually factor? Well, we're just going to make it a bit simpler than I made it before. So it's going to be just putting those numbers here and here. It doesn't matter the order. So -7, -4. And I can multiply them out again and see that I get the same thing if you want. It will become that again. Okay, let's do one more. And again, you could translate this into the box method. It's the same idea. I'm just sticking -11 here and 28 here. And then I'm thinking about 28. And I'm just trying different combinations. So what you could just do, what people do is they just write down the combinations here. So they do this. They say 20, I'll put 28 here, 1 there. And then they'll add them. Does 28 plus 1 equal -11? No. So then they erase and they try again. And they'll go to the next one. What about these two? 14 and 2. Does that add up to -11? No. So they cross it out again. Try new. So they just go down the list. But going down the list is sort of annoying because the right answer is actually the very bottom one. So you sort of can think about it ahead more. And you could realize like, well, since I have to add up to -11, none of these could work. And then if I add -28, that's already too big. -14 is already too big. So it's got to be that this one, -7 plus -4. Does that equal -11? Yes, it does. So those are the two numbers, x minus 7 and x minus 4. Okay, let's do one more. X squared plus 10, x plus 24. So what multiplies into 24? It's the first thing to answer. It's quite a lot. 24 times 1, 12 times 2, 4 times 3. I guess there's not a lot, there's just those ones. All right, sorry, 8 times 3 is 24. And 4 times 6, there's one more. Okay. So what multiplies to be 24? Those numbers. And then there's the negatives, but we're going to sort of think ahead again. The negatives, there's no way they're going to work because the negatives, they need to add up to +10. So those ones are not going to work. I'll write them, but there's no way that this can add up to +10. None of these could, because they are all just negatives added together. So these will not work. Cannot add to be 10. So it's got to be one of these. So which one of these adds to 10? Well, 24 plus 1, that's 25. 12 plus 2, that's 14. 8 plus 3 is 11, pretty close, but no. 4 plus 6, that is 10. So it's 4 and 6. So x plus 4 and x plus 6, my factorization. So once you practice a lot of these, what you start to see is this pattern of, okay, just look at this, think about its factors, and then think about if those factors add up to 10. And so we're just going to have to do a lot of practice to get good at it. Okay, so that's it for today. See you next time.